Good morning, this is Miss Billerbeck, and we're going to talk about 11.1, distance between 2 points. So the easy thing to do when we have a vertical or a horizontal line is just to count 1, 2, 3, 4, 5. So this is 5, but there's a mechanism to it that we should probably be aware of. So this point's at -9 on the X, so you walk through the lobby before you go up the elevator, and then this one's at 2. This one's at -9, and it's at 7. So we can see that if we subtract -9 minus a -9, that's 0. So there's really no change there. But if we had done 7 minus 2, we would have gotten 5. Okay, so the only difference that these 2 points had was in the y's, which we can see is it changes in the y direction. So we subtracted the y's and we got 5. Now again, if we count this 1, 2, 3, 4, 5, 6, 7, 8, we know that this is going to be 8. Then if we have this as a point here, 2, 4, and this is a point here at 10, 4, we see, well, the y's are the same, so the distance is actually, we can start using an absolute value sign too, because distance can only be positive. So 10 minus 2 gives us a distance of 8. So that is 8, just like we thought. Okay, so when we look at distance, it's easy when they're horizontal, vertical lines, 1, 2, 3, 4, 5, 6, 7, 8. And that's the difference between 2 minus a -6, which is the absolute value of 8, which is 8. And then this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Which is the absolute value between, that's 3 minus a -6 over here. So we have the absolute value of 9, which is 9. So when we have distance, when it's only involving x or y, it's rather easy to find it. Now, when we have x and y both changing, that's when it becomes a different story. So when we first look at this and we look at OC, we see, oh, okay, this one's at 0, 0. But this point here is at, we walk through the lobby first, so 3 is the x and 4 is the y. And we look at OC. So if we want the difference of OC, we see, okay, it's changing in this direction. So our length of our triangle here, we drew the triangle, we would have 3 right here. And if we drew the triangle up here, we would have 4. Well, we just learned about the 3, 4, 5 triangle, so this would be, OC would be the square root of 3 squared plus 4 squared. Because, well, let's go back. Remember, a squared plus b squared equals c squared. So we'd have 3 squared plus 4 squared equals OC squared. Which means if I wanted to find OC, I could rewrite this as OC is the square root of 3 squared plus 4 squared. Okay, so that's going to be OC is going to be the square root of 9 plus 16, which gives me the square root of 25, which is 5 units. So now we know this is 5 units. Now if we take the same line, but we just move it away from the origin, so this line here is exactly the same length. Okay, so if we take a ruler and we're like, okay, that's going right here, and we take it and we measure it right here. Yep, they're the same length. Okay, but they're in different locations, so we can't just say, oh, that's 3 and that's 4. Okay, so what we're going to do is there's a formula for this where we could actually say, okay, so it's going to be a triangle here. So we're going to take this triangle here and this triangle here, and this side here. So this side here, this side here. Sorry, not triangle, but this side. Okay, so if we take the difference here, we see it's 1, 2, 3, which is the absolute value of 5 minus 2, which is 3. And this one's the absolute value, and we are at 5 minus 1. So the absolute value equals 4. Okay, so now we can do the Pythagorean theorem, but let's set it up like this, where AB equals the square root of A squared plus B squared. Okay, and then let's say instead of writing A, let's actually write those absolute values. So we're going to have the absolute value of 5 minus 2 squared plus the absolute value of 5 minus 1 squared. And that's going to give us AB equals the square root. And then we have 3 squared plus 4 squared, which gives us the square root of 9 plus 16, which is the square root of 25, which is 5 units. Okay, but instead of writing an absolute value sign, if we square something, it's just going to be positive. So now we don't really need, when we're squaring an absolute value sign, we don't really need the absolute value sign. So we could have written it like this and gotten the exact same answer, because when we square it, it is going to be positive, just like those absolute value signs do. They wash away any negatives. So we could write the equation like that and get the exact same result. So what this does is it introduces the basic equation for the distance between 2 points, A with x1, y1 as a coordinate. Now the 1 in the subscript is just a name. It's not an exponent, it's only a name. So that just means this is a particular point, particular x, and this is a particular y. It's just, this is my first point. And when I use x2, that's my second point. So if I'm given these 2 points, then the distance AB of line segment AB is given by the square root of x2 minus x1 squared plus y2 minus y1 squared. And basically, AB is the hypotenuse of a right triangle, just like we've seen here, because when we take a line segment, we make a right triangle here. So we have the x value and the y value, the x value and the y value, and both of these are right triangles. So we can apply the Pythagorean theorem. So basically the distance formula is the Pythagorean theorem written out in a slightly different way. All right, so if we're given these, it says find PQ. So I have PQ here. So PQ, I'm going to take the square root of, and I'm going to say this is x1, y1. I'm going to say this is x2, y2. And I'm going to say this is x3, y3. So if I have -4 minus -7 squared plus -2 minus -4 squared equals, and then I have the square root. So I have -4 plus 7 squared plus -2 plus 4 squared. So then that gives me -4 plus 7 is 3 squared, and then -2 plus 4 is 2 squared. So PQ then ends up being the square root of 9 plus 4, which is 13. Okay, so QR would then be the square root, and we're going to do x3, which is the 2, minus -4. Now it doesn't matter which one goes first on the x's because I'm squaring it. So it doesn't matter. The negatives are going to go away. Okay, what does matter is I can't mix an x and a y. I can only subtract x's, and I can only subtract y's. So it doesn't matter if you mix them up, the square is going to take care of anything but any negative sign. So we have 2 minus a -2 squared. So that's going to be the square root of -2. I have a positive sign here because there's 2 negatives. So 2 plus 4 is 6 squared, and 2 plus 2 is 4 squared. And that equals the square root, and that's 36 plus 16. So that gives me a square root of, let's see, that's 4252. 52, if I divided 52 by 2, I get 26. So, oh, there is a little bit of something I can take out of that one. So, so it has a pair. So the square root of 52 can be reduced to 2 square root of 13. Ah, so they're both square root of 13. There is a pattern here. Okay, so PR, the whole thing. So PR is going to be square root, and then I have 2 minus a -7 squared plus 2 minus a -4 squared, which gives me the square root. Let's see, the square root, and then I'm going to have, that becomes a positive, so it's 9 squared plus 6 squared, which is 81 plus 36. So 81 and 36 gives me 117. Now I'm betting 117 can be reduced because 1 plus 1 plus 7 is reducible by 3. So let's take a 3 out, and that gives us 3, 9, and then I can take another 3 out, and that gives me 13. We have a 3 we can take out, so this becomes 3 square root 13. Okay, so it says, does it add, are all these on the same line? Well, if they are, then I should be able to add PQ, the distance PQ, plus QR, and that should equal PR. So I have radical 13 plus 2 radical 13 equals 3 radical 13. And And that is actually true because there's really a 1 there. So we can add this like 1a plus 2a equals 3a. So that is true. 3 radical 13 equals 3 radical 13. So they are on the same line. So I could draw a line right there and connect all of these. And we can see quickly that, yes, they are on the same line right there. Okay. All right, the last one. So if we're given triangle PQ, and then this is R right here. So PQR. Okay, so we want to find PQ. So PQ, let's look at the coordinates. So first we do the lobby, which is the X. The X is the lobby, the elevator is the Y. So this is 3, and then this is 2. R is at 4, so 4, and then -1. We drop down on the elevator. Q is at, that's at -3 and 0. All right, so PQ. If we look at PQ, we have PQ equals the square root, and P is here. So we have the x's are 3 minus a -3 squared plus, and then we have 2 minus 0 squared. So PQ is going to be the square root. This is a positive here, so it's 3 plus 3 is 6, so it's 36. And 2 squared is 4. So we get the square root of 40, which reduces, because we can take 40 and we can take 2 out and get 20, take 2 out and get 10, take 2 out and get 5. And so that gives us a 2 that we can take out. So this is 2, and then what's left over is square root of 10. Okay, so PQ is 2 square root of 10. All right. Now let's look at QR. So QR, we have QR, so our x's are 4 minus -3 squared plus -1 minus 0 squared. So QR equals the square root, and this becomes a positive, so it's 4 plus 3 squared is 49. And this becomes -1 squared, which is 1. So this is the square root of 50. Okay, so if we break 50 down into a prime factorization tree, 50, we take a 2 out, we get 25. Get 5 out, 5. So we have a pair right here. So this is going to be 5 square root 2. Because the 2's alone, so it stays home. All right, so we have this one is going to be 5 square root 2. Now we're going to look at RP. So RP, whoops, let me write P, is going to be right here. So we have the square root 4 minus 3 squared plus -1 minus 2 squared. So RP then is going to be the square root of 1 squared, which is just 1. And then that's -1 minus 2 is -3 squared, which is 9. So that gives me the square root of 10. So RP is the square root of 10. All right, so it says show it's a right triangle. Well, now we have to go and do the a squared plus b squared equals c squared. So let's say this is square root of 10 is close to 3. So this is close to 6. And square root of 2 is 1.2-ish. So that's close to 6 too. So it's really, when we look at the drawing, we see QR is the longest. So this must be the biggest one. So we're going to do the square root of 10 squared plus 2 square root of 10 squared should equal 5 square root of 2 squared. So this is 10 plus, and 2 squared is 4 times 10, this 10 is in there, equals 5 squared is 25 times the 2 that gets released from that. So we have 10 plus, and that's 40 equals, and that's 50, and that checks. So it is a right triangle. So we just showed that it's a right triangle. All right. So find the perimeter. Well, the perimeter, we add everything up. So perimeter equals 2 radical 10 plus radical 10 plus 5 radical 2, which can be simplified to 3 radical 10 plus 5 radical 2. Okay, so let's see. Probably want to find a better place to write that. Okay, so this simplifies to 3 radical 10 plus 5 radical 2. Okay, the area, well, the area, we don't use the hypotenuse. Okay, so the hypotenuse is the longest side, which we found was the 5 radical 2. So the area of a triangle is 1/2 base times height. So the base and the height are the 2 legs of the right triangle. So it's 1/2 times PQ, which is 2 radical 10 times radical 10. Well, radical 10 times square root of 10 times square root of 10 is 10. So we have 1/2 times 2, and then square root of 10 times square root of 10 is just 10. So this cancels, and we have 10 square root of 10 times square root of 10, which is 10. So it's square root of 10 units. 10 square units, sorry. 10 squared units, and this one's units. All right, so there we have it. That is how we find the length of the line segments. It's how we find if it's a right triangle. We find the perimeter by adding up all the sides, and the area, we take the 2 legs that form the right angle right there. That's the right angle, and that's the hypotenuse. So we only take this leg times this leg and times 1/2 to get the area. All right, that's it for this lesson. You have a wonderful day. Bye-bye.